Hello student, let's try to understand the chemical properties of phenol student. The first reaction is halogenation student. The important one is bromination. If you are doing bromination in the carbon disulfide student, ortho and para bromophenol is forming. But if it is doing the bromination in water student, it is going to give the 2,4,6 tribromophenol. This is the white PPT. If you are going nitration also dilute nitric acid, it will give ortho or the para nitrophenol, but it is the concentrated nitric acid 2,4,6 trinitrophenol, that is also called picric acid. Sulfonation. So it is going to give the 373 Kelvin student, it is going to be para hydroxy benzene sulfonic acid, but it is less temperature, it is going to ortho hydroxy benzene sulfuric acid. Friedel-Crafts alkylation student, ortho and para cresol it will give, but here if you are talking about the chloroform and NaOH student, you are treating with the chloroform and NaOH, and then hydrolyzing student, it is going to give student salsaldehyde. The reaction is called student Remer-Tiemann reaction, right? Now if you talk about you are treating with the NaOH, then CO2, and on hydrolyzing it will give the salicylic acid. The reaction is called the Kolbe reaction. Student, here this reaction is not there in CBSE, but if you are treating with the acid chloride in presence of anhydrous AlCl3 in CS2, so it will give the what it is going to give student para hydroxy acetophenone. This is called student Fries rearrangement. Para hydroxy acetophenone, it is called Fries rearrangement. Orthohydroxy acetophenone and para hydroxy acetophenone. Next one student, you are treating with the what? Diazonium chloride student. So para hydroxy azobenzene it will give student. It is orange red dyes. This is called the coupling reaction student. Next one is student, if you are treating with the HCHO and water, it will give bakelite student. This is also not there in CBSE student. This reaction and this reaction is not there CBSE student. Okay, so it will give student bakelite if you are treating with the formaldehyde. Zinc dust student, if you are treating with the zinc, it is reduced to benzene. If you are treating with the sodium dichromate student in the acidic medium, it will give benzophenone student. If you are treating with the neutral FeCl3 student, it will give the ferric phenoxide student. It is the violet color used for the enolic group student, is for enolic group. So what you got to know student, there are many reaction in this one, and what are these reaction you got to know. The first one with Br2 student, Br2, if you are taking the CS2 student, so para bromophenol it will give, but if you are bromine water you are taking, so it will give the 2,4,6 student, 2,4,6 tribromophenol, that you need to memorize student. Nitration also, dilute nitric acid means orthonitrophenol student, and concentrated nitric acid para that is 2,4,6 trinitrophenol, also called the picric acid student. If you are treating with the sulfonation 373 Kelvin, it will give para hydroxy benzene sulfonic acid. Friedel-Crafts alkylation student, so ortho and para cresol it will give student. And if you are treating with the chloroform NaOH and acidification, it will give salsaldehyde. The reaction is called student, that is Remer-Tiemann reaction, right? If you are treating with NaOH and CO2 student, it will give the salicylic acid. The reaction is called Kolbe reaction. Okay. Acid chloride in presence of anhydrous AlCl3, it will give the para hydroxy acetophenone, that is called Fries rearrangement. Coupling reaction with the diazonium chloride student, it will give para hydroxy azobenzene. This is the orange color dye student. Okay, reaction is coupling reaction. If you are treating with the formaldehyde, it will give bakelite student. Treating with the zinc dust, it will give benzene. Treating with the sodium dichromate student, it will give the benzoquinone. If you are treating with the neutral FeCl3, it will give the what student? Ferric phenoxide, violet color. Thank you student.